Hey everybody, we're at the Come and Go to get coffee. Today we're going to be going to the Plantation Agricultural Museum, and we're going to be going to the Toltec Mounds Archeological State Park. If you saw our last video about Town of Wilson, then you will enjoy this video because it's a good follow-on to that. The same type of history will be covered, both the prehistoric peoples in the Arkansas region and also the modern era of cotton industry in Arkansas. So let's go. Okay, we made it to the Toltec Mounds Archeological State Park. Let's see what the visitor's guide has to say. A National Historic Landmark, one of four in Arkansas State Park System, this park interprets the largest and most complex mound site in the state. It also offers the rare opportunity to see archaeological research at work. This site was a ceremonial ground for prehistoric Native Americans and stands today as an important and fascinating piece of history. Located 4 miles from Scott, a short and beautiful drive from Little Rock. So we're going to go check out these mounds. This is about the prehistoric peoples of Arkansas. And then later we're going to go down the road, only 5-minute drive, and that's going to cover the history and industry of cotton in the state. It's interesting how the building is built into the ground as if it's a mound.
Monsignor Vaughan informed me of the remains of an aboriginal station of considerable extent, resembling a triangular fort, which the Quapaws, on their first arrival in this country, say was inhabited by a people who were white and partly civilized, but whom at length they conquered by stratagem. The hunters possess an opinion, by no means singular, that this embankment is of antediluvial origin.
We were attracted to the place by the immense artificial mounds and a wall similar to our levee, about 6 to 10 feet high, enclosing 90 acres, or rather coming around a half circle to the lake bank, which in those days might have been the Arkansas River. In the walls are 2 openings, both deep pools of water. With the area between the lake and the wall are numerous mounds, but only 2 of great size.
That the Little Rock branch of the St. Louis, Arkansas, Texas Railroad will be completed to this city within 10 days from this date. The arrival of the cars of this road will be an important event in the history of Little Rock, and one of the stations on this railroad, about 18 miles east of Little Rock, there are the most extensive and important works of the mound builders existing in the Southwest. It is a theory of the writers of the prehistoric remains of the Mississippi Valley that the mound builders were of the same race of people as the first settlers and builders of the city of Mexico, the Toltecs. Accordingly, in honor of its prehistoric inhabitants, the name of Toltec has been given to the station and town at this place.
This site was the year-round home to tribal leaders and their families, and it was the capital city of a large population living throughout the surrounding area. Daily routines here were interrupted when the site was transformed into a busy capital city by hundreds of people gathering in the two plazas to renew social ties, play games, and enjoy a ceremonial feast. Forests offer an abundance of resources and provide the necessities to build a civilization. The Plum Bayou culture used the plants and animals of the surrounding forest for food, water, shelter, and clothing. The vast, lush, bottomland forest along the Arkansas River was their supercenter. Cotton pins were small buildings used to store cotton in the field until a wagon could take the cotton to the gin. A pin held 1,500 pounds of cotton, enough to make one bale. Cotton pins could be moved by pulling them on their skids. This was one of around 100 pins that were on the J.R. Alexander plantation near Scott in the early 1900s. Cotton is planted annually, usually in May. By midsummer it blooms and then develops into a boll that splits open when mature. The boll contains the cotton lint, or fiber, and a large number of seeds. The fiber surrounds the seeds and varies in length. Cotton harvesting typically begins in September. Cotton was the primary cash crop in Arkansas from around 1836, when Arkansas became a state, until World War II. It was the thriving force in the plantation system and then the sharecropper tenant-farmer system that developed with the end of slavery. From 1836 until World War II, the way cotton was grown and harvested changed very little. Laborers prepared, fertilized, planted, and cultivated the fields by hand, aided by animal-drawn implements. Even in the early 1940s, workers were picking cotton by hand. World War II changed all of that. The war and changing economics forced plantation owners and farmers in general to mechanize due to shortages of labor and mules, which were both in demand for the war effort. The area you see in front of you was once a railroad spur of the St. Louis Southwestern Railway, better known as the Cotton Belt Railroad. In an era before interstate highways, railroads moved cargo and passengers. Cotton bales were hauled by rail from Scott to Market, or to the Federal Compress to be reduced in size. The seed cotton was vacuumed out of the wagon using the suction tube. This is where the ginning process began. The suckman stood in the wagon and used the telescoping suction tube to vacuum up the seed cotton. Powerful blowers inside the building provided the vacuum needed to pull the cotton into the suction tube. The pulley and rope connected to the tube acted as a counterweight, making it easier to move the suction tube. A long line of wagons at the gin was a common sight during cotton picking season. Once a loaded wagon reached the front of the line, it was driven onto the wooden platform. The platform is connected to a scale inside the building. The wagon and its load was weighed, and then the cotton was sucked out. A wagon holds about 1,500 pounds of seed cotton, enough to make one 500-pound bale. This cotton gin is equipped with an air duct system and other improvements invented by Robert S. Munger. By 1890, the Munger system was used in gins throughout the South. By using either vacuum or blowing, the Munger system moves seed cotton from the delivery wagon to the gins and the cotton lint to the press for baling. This system also removes cottonseed and debris from the building. Blowers provide either a vacuum or a blowing effect, depending on what side of the blower the air duct is connected. The blowers pull air into the system through the air intake tubes. Inside the blowers are rotating fan blades shaped like paddles. Before Munger developed this blower and duct system, cotton was carried to the gin and the press in baskets and fed into the gin strands, all by hand. Small cotton fibers would float in the air, causing a breathing hazard to workers and a fire hazard. Although it did not eliminate all the hazards, the Munger system did reduce them while increasing productivity by eliminating much of the hand labor. A series of pulleys and belts on a shaft is used called a line shaft. The line shaft gets its power from the engine through the main drive belt. The line shaft spins, sending power through its other belts, making it possible to operate several pieces of equipment from one engine. The pulleys are different sizes in order to turn the belts at different speeds. Large pulleys turn belts at faster speeds. Small pulleys turn belts at slower speeds. Each piece of equipment operates at a different speed. Pulley size regulates that speed. This is a 2-cylinder Fairbanks Morse 75 horsepower diesel engine. Diesel engines like this one were powerful, reliable, and built for heavy-duty work. Once they were started, diesel engines could run as long as necessary, with fuel, oil, and water being the only supplies needed to keep them running. Gins ran 24 hours a day, 7 days a week during the ginning season. Having a reliable engine kept them in business. As the cotton is being removed from the wagon outside, it is sent through the suction tube and pulled by vacuum to a transition duct in the unloading system. When the cotton builds up and covers the screen, the suction from the fan cannot hold the weight, and the cotton drops into the feeder. The feeder prepares the cotton for ginning by breaking up the cotton locks, dislodging the burrs, dirt, and debris, and then distributing the cotton evenly into the gin stand. This helps the gin stand work efficiently. Inside the feeders are cylinders covered in coarse saw blades, brushes, and rollers that pull the cotton apart and move it through the feeders. The loosened seed cotton drops into the gin stands below at a steady rate. These Mitchell seeders were an improvement added to the gin plant around 1930. Gin stands separate cotton fiber, or lint, from the seed. These continental gin stands each have 80 saw blades that pass through metal slats called ribs. The space between the ribs is too small for the seeds to pass through. With these sharp teeth, the saw blades grab the lint off the seeds, pulling it through the space between the ribs. The seeds drop out of the front bottom of the gin stand into the seed auger and are pushed out of the building. Behind the ribs and saw blades is an array of brushes mounted lengthwise on a cylinder. These brushes remove the lint off the saw blades. The spinning brushes create a huge volume of air, which blow the lint out of the back of the gin into the lint chutes and to the condenser that fills the press. Now that the cotton and seed have been separated, the cotton lint must be collected and compressed into bales for shipping. Inside the condenser, cotton lint is collected in thin bats on a revolving, mesh-covered cylinder. A roller, pressed against the turning cylinder, forces air from the lint before it is dropped into the press box. The last step in ginning is pressing the cotton lint into bales. This press is on a circular platform so the two boxes can be rotated. While the nearest box is being filled with lint, the other box, already full, is pressing the lint into a bale so it can be bagged and strapped. While the press is still holding the bale in place, the front of the box is opened and the bale is tied with metal straps and tagged. Burlap or jute bagging is already in place to protect the bale. Finished bales are rolled through the door in front of the press to the loading dock. Cotton lint is made into a bale in order to ship large amounts of cotton in a small package. The part of the press that provides the pressure to compress the lint into a bale is on the ground floor under the press box. It is hydraulic or liquid-powered and is called a hydraulic ram. An electric motor pumps oil to the hydraulic ram, which contains a piston. As oil is pumped into the ram, the piston rises to the bottom of the press box, forcing it up and compressing the lint into a bale. In 1948, Robert L. Dortch of Scott, Arkansas, constructed Seed Warehouse Number 5 to accommodate his expanding commercial seed operation. This location was chosen because of access to the highway and to the Cotton Belt Railroad, a railroad spur connected to the old main track. The warehouse design included auger systems in the floor and ceiling, improved ventilation, and sloping sides to accommodate the shape of the huge seed piles. This seed warehouse was built to correspond to the angle of repose, which is how cotton seeds naturally pile. Truss construction eliminates the need for interior supporting columns, leaving most of the floor open. Seed Warehouse Number 5 was acquired by the Arkansas State Park System in 1985 as part of the Plantation Agriculture Museum. In 1919, a group of Arkansas growers formed the Arkansas Seed Growers Association. Their goal was to produce and sell pedigreed seeds for planting. Dortch became a member of the executive committee. The association developed standards for the production of pedigreed seeds. Pedigreed seeds have a recorded line of purebred descent. They are bred for predictable yields, disease resistance, and weather tolerance. Dortch's pedigreed seeds were tested in demonstration plots for all of these factors. Once harvested, seeds were inspected, graded, cleaned, and certified by the association. Dortch took extraordinary precautions to ensure the purity and stability of his planting seeds from the time they were sown until they were marketed. Individual plants that displayed off-breed characteristics were removed from this field. The plots for pedigreed seed production were spaced apart to prevent cross-pollination. By storing the seeds in this warehouse, Dortch could ensure that the seeds were kept cool and dry to prevent heat damage. The fanning mill cleaned grains using a fan and a series of vibrating flat sieves lined with coarse, defined screens. The seeds moved through the sieves and dropped to the bottom as debris was blown away by the fan. The arrangement of the sieves depended on the desired size, weight, or shape of chosen seed. Vetch and oats were often grown and harvested together in a process called intercropping. This separator used only gravity and the spiral design to sort the vetch from the oats. The two seeds were shaped differently and would travel down the spirals at different rates of speed. The faster, more rounded vetch seeds flowed out one spout, and the slower, usually flatter oats were deposited out the other. A pea huller saved valuable time during the harvest of commercial crops by removing the peas from the pods, or hulls. Pea hulling machines made fast work by running the hulls through a set of spiked rollers, separating the pods from the peas. Grains, peas, and beans needed to be cleaned in an efficient manner before they were ready for sale. Seed cleaners accomplished these processes using brushes, vertical blast fans, and vibrating screens to remove light chaff, waste, and dust, leaving only fully developed seeds of uniform size. This rolling fire extinguisher may have been at the warehouse or a nearby cotton gin. It contained two chemicals that, when mixed together, pressurized the tank and forced a fire-retardant mixture out of the hose. Recently ginned cottonseed had higher moisture content and needed to be kept dry and ventilated. The longer moist cottonseed remained in a pile undisturbed, the more heat was generated. If conditions were not closely monitored, enough heat could build up to start a fire. Workers constantly looked for hotspots to avoid a potential fire hazard. Steam rising or hot-to-touch areas were quickly stirred. To remedy hotspots, electric-powered blower tubes were inserted into the piles to cool and dry the seed. When cottonseed arrived at the warehouse, it contained dirt, sand, cotton burrs, and debris. This cleaner moves seeds over a revolving screen called a sand and bowl screen. The tumbling action of the cleaner shook much of the debris from the seeds. A powerful blower assisted by directing a stream of air strong enough to blow away the remaining debris. The cleaned seed was ready to be bagged or sold in bulk. This cleaner was designed and built by Robert L. Dortch. The Dawkins seed grader used screens and an oscillating action to sort rice and other grains according to size. It organized seeds into uniform-sized grains for sale or planting. This device could broadcast seed, usually grass, oat, or clover seed, while the wagon was driven back and forth across the field. The chain-driven seeder cast the seed in a wide swath. This is a 1952 John Deere 2-row cotton picker. It could pick in 1 hour what it took 80 men to do. With a picking speed of 2.5 miles per hour, the 392 spindles plucked the cotton lint and blew it into the 800-pound capacity basket. This is a 1910 Peerless steam traction engine. Except for its wheels, which allowed it to be moved, the steam traction engine operated under the same principles as any steam engine. The J.I. Case and Geiger Peerless steam engines were used from about 1890 until 1920. These massive engines could be driven to various locations where they provided power to threshing machines, grist mills, and sawmills. Although great labor-saving devices, they were dangerous to operate and required constant attention. It was essential that the ceiling of the firebox, called the crown sheet, be covered with water at all times. Allowing the crown sheet to become dry and then attempting to feed water into the boiler could result in a disastrous explosion. During the 1920s and 30s, tractors quickly replaced steam traction engines. Farmers appreciated the gas models for their portability, horsepower, safe operation, affordability, and need for less maintenance, fuel, and water. Popular options included electric start and lights. Gas models cost less than half as much as steam traction engines. 1928 tractor models averaged $900. Many also offered power at 3 points, belt pulleys, drawbar, and power takeoff, providing power for many more attachments. Well, that about does it. We learned about the history of the cotton industry in the Delta, and we revisited the ancient ancestors of Arkansas. I hope you enjoyed the video. We'll see you down the road on the next one.